Okay, so we're back here, Math 20-2 in our booklet. We're on page 237, and we're going to be learning about problems involving the normal distribution. So basically, this is just a few problems, word problems that we're going to use our knowledge of standard deviation, mean, z-scores, etc. to help us solve. Okay, and then of course, knowledge of our bell curve. Okay. So just to, here's the photocopy of the same page that's in the back of the book. So we're still going to be using this formula. So our z-score, the actual value, the mean value or average, and then sigma, which is the standard notation. Okay, and then that's the area. So the z-score is the area underneath the curve. And of course, it's all in decimals. And it represents the percentage of the area. And so we can also use, I'm just going to open our standard deviation. We're still going to be using this right here. So our mean is the center, and then each section there is one standard deviation away from the mean. Okay, and all these numbers are adding up to 100%, because that's representing 100% of our data, whether it's test scores or people in a population, etc. Okay. So back to page 237, starting off with a light bulb question. So a light bulb manufacturer produces 35,000 light bulbs, so that's our total number of light bulbs. From past data, the lifetimes of the bulbs are normally distributed with a mean life of 900 hours. Okay, so mean life, that's going to be our mu, and then down on our bell curve, okay, that's going to be our mean there. Okay, and they have a standard deviation of 50, so that tells me my sigma right there. Okay, so then each standard deviation is 50 hours. So the question is, predict the percentage of light bulbs that will last between 825 and 875 hours. Okay, so this is going to be 2 data points. So this is going to be, I'm just going to call it my x1. And this is going to be called my x2. Okay, so if that's 900, and I'm looking at these two, so then 875 is roughly there. I'm just going to put an arrow to it, 875, and then 850 is going to be there. 850. Okay, so that's what I'm going to be trying to find out. So my z-score for the 825, or sorry, I labeled this wrong, sorry guys. That second one is 825. I put 850, okay? So my z-score for 825 is going to be, so any z-score, x minus your mu divided by sigma, so that's all we're going to do here. We're just going to substitute in the values for this example. So my x is 825. My mu is 900. My standard notation, standard deviation is 50. Okay, so then I do 825 minus 900, and then I divide that by 50, and you'll get a z-score of negative 1.50. So that's the first thing that we have to do. The next thing, so we did the z-score for this. Well, now we need to do the z-score for 875. Okay, so it's going to be exactly the same because we're using the same formula. It's just that now I'm going to have, instead of 825, I've got 875. So then that z-score is going to be negative 0.50. So in order to find my actual percentage between the two, so then what that's going to be, okay, I'm going to take those two terms. Z is going to be in between these two values that I just calculated. Okay, and so remember the probability of that is going to be equal to the bigger one subtract the smaller one. Okay, so now that I've got this set up, now remember, this right here is a z2 minus a z1. So now I'm going to be going to my table here, and I go down to 0.5. Okay, and so the negative 0.5, and then I go over here, okay, is 38.5. Okay, so 0.3085, and then I do negative 1.5, which is up here, negative 1.5, and remember I go over, and the reason why I'm going over is because it's 1.50. There's no third, or there's no hundredth place. Okay, so then that's my number there, 0.00668. So then I would put that into my calculator, and I would get 2417. And since this question specifically asks for the percentage, I'm going to go ahead and put that in percentage. So 24, it looks like a 7, but it's a 1. 24.17. Okay, so that's part A done. All right, so how many of, second question, I think I'm going to use a darker pen. How many of the 35,000 light bulbs would you expect to last between 825 and 875 hours? Okay, well, we take that number and we're going to multiply it by that percentage. Now, when we multiply it by, we're going to leave it in our decimal form. And so then that means, so 24.17% of the total number, we would plug that into our calculator, and we would get a number of 8,460, and then we'd put our units of bulbs. Okay? And then the last part of this question, determine the probability that a bulb selected at random will last less than 920 hours. Okay, so first off, we need to remember our mean is 900, okay? And then from there, we're going to place the 920, okay? So if we put that right there is 920, and then the terminology here, less than, so that means that's the area that we're looking for. So we need to find out our z-score so that we can find the area underneath the bell curve. So z of 920, so this is going to be exactly like up here, except for we just have one value. So then that's going to be 920 because that's my mean. My mu, or my average, or my mean is still 900, and my standard deviation is still 50. So 920 minus 900 divided by 50, we would put that into our calculator, and we would get a z-score of 0.40. Okay, so then 0.40, we would want to, now this one's the positive one, right? So 0.40 is 0.6554. 0.6554. Okay, and that's the area underneath. Oh, move that down. Underneath right there. Okay, so that's the probability that a bulb selected at random will last less than 920 hours. Okay, so you just have to remember that the probability is going to be equal to the area underneath that z-score. Okay, so that's the first example. Second example, a study showed that the mean duration of a certain strain of flu virus was 12 days. Okay, so the mean duration, that means that that's our mu, or an average. And then a standard deviation of 3 days. Okay, that's my sigma. If the data is normally distributed and you caught this strain of flu virus, determine the probability to the nearest hundredth that it would last longer than 17 days or between 13 and 15 days. Okay, so things to pay attention to in this question, whatever our answer is, okay, so we'll revisit this. It needs to be the nearest hundredth, so just 2 decimal places, and then we've got 2 different things we need to answer here. So remember our mu is 12. So just as a reference point, we need to write that down. And then if it's longer than 17, okay, this is what I'm trying to find out. Okay, if it's between 13 and 15, okay, so there's 13, there's 15, 13 to 15 is that area that we're going to try to find out. Okay, so my z-score, I'm going to use my formula, okay, which remember is x minus mu divided by sigma. That's my actual data value, that's my average, that's my standard deviation. So I just have to plug it all in. I labeled them all up here. Okay, so that's going to be 17 minus 12 divided by 3. And then when I actually plug that into my calculator, that gives me 1.67. Okay? So now, in order to get my actual probability, okay, so this was the first thing I had to do. Second thing I have to do, which I'm going to just squish down here, second thing I have to do is figure out my probability of z being less than that, or sorry, greater than that 1.67, okay, which remember, if it's going that way, I have to subtract 1 minus the area of that z-score. Anytime you're calculating anything to the right, you have to subtract it from 1, okay, because the z-scores go towards the left. So then that's going to be 1 minus, and so then you go 1.67, so that's our positive, so we would go to our sheet. There's my 1.6, so I'll move this up. There's my 1.7, so I would, there it is, 0.9525. 0.9525. Okay, and then once I plug that into the calculator, I would get that value. Now here's where I need to revisit what the question stated. It said to the nearest hundredth. Okay, so that means that 7 is going to round up that 4, and my final answer will be 0.05. So the probability, oops, let's move that down a bit, will be 0.05. Okay? Okay, so that was the part A, which was a greater than situation. Now we want to know between 13 and 15 days. Okay? Move it over. So we're still going to use the same formula, but this is going to be more like our example up here where we had the two terms and we needed to figure out the distance between them underneath the bell curve. So I'm going to have the first thing I do, I'm going to try to keep this organized because they didn't really leave us a terrible amount of space. So Z for 13, so I'm still going to use this formula, so my data minus my average divided by my standard deviation, which is going to look like 13 minus 12 divided by 3, okay? And then I still need to do my Z of my 15. I'm just going to show you how, I just really want it drilled in that it's the same formula. The only thing that's changing is because we've got those new data values, okay? So when you plug this into your calculator, you're going to get 0.33, repeating, and then this is actually going to be 1.00. Okay, so the Z13, 0.33, Z15, 1.0. Okay? So now we want to figure out the probability of those two. So I'll just move this down. So the second thing that we're going to do, so the probability of the 0.33, okay, like that, because the 13 was the 0.33. So this is 0.33. This right here is 1.00, so that's why I wrote it like that. Z's in between the 0.33 and the 1.00. Okay, so then we want, this is going to be equal to the area of the 1.0 minus the area of the 0.33, and of course those are going to be our Z scores. So then we go to 1 and 0.33, so those are both going to be the positive ones. So 1.0, oops, helps if you can see. The 1.0, that's going to be 8413. Okay, and then the 0.33, so we would go up to the 0.3, and then over to the 0.3. Oh, my computer fell asleep. Just got to wake it up. Wake up, computer. Okay, so then that's going to be 0.6293. 0.6293. Okay. So then we would plug that into our calculator, and we would get a value of 2120, which of course we're not done yet because the question told us to the nearest hundredth. Okay, so now that 2 is not going to do anything to that 1. So our probability here would be 21. So, and remember that these represent percentages. So if I put this into percent, so I would have a 5% chance of it lasting more than 17 days, and I'd have a 21% chance that it would be between 13 and 15 days. Okay, so overall for any of these examples, okay, I'm using my bell curve, I'm using my z-scores, I'm using this formula, okay? So let's do, there's a few more examples, 3 to be exact, okay? So, from extensive testing, an appliance distribution company knows that the average life of toasty toasters is 4.2 years. So notice they said an average life. Okay, well that means that that value right there is my mu. The standard deviation is 0.65 years. Okay, that's my sigma. And the data is normally distributed. The company does not want to replace under warranty more than 8% of the toasters that are sold. Okay? So that's going to mean something we're going to talk about in a second. What warranty to the nearest year should the company offer? So after 1 year, 2 years, 3 years, what's up? Okay, so this is our percentage here. And so remember, our percentages, those are going to be our z-scores. Okay, and 8% in a decimal is going to be 0.08, sorry. Okay, so 0.08, okay, 0.08 is our first z-score, 0.08, okay, and actually I got ahead of myself. We don't actually know where that is, right, because that just represents the area under the curve. So what we would have to do first is figure out what side is it on. So just pretend that, you know, I didn't just spoil that for you. Okay, so the area of the z curve is 0.08, and then from there, where's my positive? 0.08, okay, 0.08 is, so we need to find this 0.08. There's some 8s. Maybe not. Okay, so that's pretty close. The negative 1.4. So because these are both close, so in order to get this to 0.08, we would need to add 7 thousandths. In order to get this down to 0.08, we would have to subtract 8 thousandths. So technically, this is the closest one. So then we would read that as negative 1.41. Okay, so sometimes you're going to have to decide between two, and it'll just be whichever one is closest. And this one, it's just by that 1 thousandths, but actually that's because 10th, 100th, thousandths, 10 thousandths, okay? But it's still it. So negative 1.41 is our Z1. Okay? So then, since it was negative, that's how I knew to write it over there. So sorry for spoiling that for you. Okay, so we've got that written out. We also want to write out that this is our mu of 4.2 years. Okay, and our standard deviation is that 0.65. But we'll use that in our formula. Okay? All right, so then our formula of z is equal to x minus mu over theta, okay, is we're going to plug everything in, and we've got the z, we've got the average, we've got the standard deviation. So what we're actually looking for is the x. Okay, so we did questions like this in lesson 3, but now it's an actual word problem. So I'm going to substitute everything in and then rearrange for my x. You could, of course, use algebra and solve for x first, which maybe I'll just show quickly here. Okay, so you would have to cross multiply that sigma. Okay, because then that's going to get rid of, so you're multiplying both sides by sigma, that cancels out. Okay, now I need to get rid of this mu, so it's being subtracted right now. So then I would need to add it to both sides, so minus mu plus mu is no mu. And then we would have, oopsies, z sigma plus mu is equal to x. So I like solving for my formula first this way, but if you want to substitute in here and then solve, that you can totally do that. Okay, so I'm going to substitute in from here. So my z is negative 1.41. I'm multiplying it by my sigma, which is 0.65. Okay, and then I'm going to add my average, or my mu. Okay, and so then when you plug this in, when you multiply these two together, and then add 4.2, okay, you get 3.2835. And I do suggest you actually put this in, because you have to practice doing this. Sometimes different calculators will multiply these, so you might need to put brackets there, but it's up to you to know how your calculator works. Okay, so we've got a value of 3.2835, and that represents our years. Now, because it says to the nearest year, okay, well then that's going to be 3. Okay, so they should offer a 3-year warranty in order to, since they don't want to replace more than 8% of the toasters. Okay? All right. So let's look at this class example 4. It was found that 62.3% of the shrimp harvested at Shrimp Harvest Farms had a mass of more than 135 grams. So I'm just gonna put the more than. That's gonna tell us that it's going towards the right. If the data is normally distributed and the mean mass of the shrimp was 146, okay, so 146 is right there. Determine the standard deviation to the nearest tenth. Okay, so we are looking for sigma. So back to our original formula. Okay, this is what I'm looking for. So if you remember any of our other algebra lessons, remember when what you're looking for is in the denominator, okay, these guys can switch places through cross multiplication, okay, because essentially the actual math behind it, you would multiply both sides by sigma, divide both sides by z, okay, and so sigma over sigma is equal to 1, z over z is equal to 1, so then we're left with an overall equation, simplified equation of that, okay, x minus mu divided by z. So that's the equation that I'm going to use to help solve this. Okay, but first we have to figure out what's going on in the diagram here. So remember, it says had a mass of more than 135 grams. Well, if this is 146, okay, that means that 135 is down there, and so I'm looking for the greater than 135. Okay? So if my x is equal to 135, my mu is equal to 146. Okay? And then from there, I need to find out, so before I can use this formula, I need to figure out my z-score. And in order to figure out my z-score, okay, I need to do my area under my curve. So since it's going this way, once again, it's going to be 1 subtracted by whatever this is representing. Okay? And this is representing, so remember up here, it was found that 62.3% of the shrimp had a mass of more than this. So that means this area right here, okay, or this z-score, okay, is 62.3%, which we would just put into our decimal form. And so then that's what is going to get subtracted by 1. So you would put that into your calculator, and you would get that, okay? So then you would go to the 0.3770, okay, if that's the area. So once again, we're working backwards here. So 0.377, okay, so we need to find 0.377. Okay, there's the 0.3s. So there's 72. 0.372 would be negative 0.42. Let's see if we can find another one. What was the number again? Oh, 77. So not that one. That was a 3. Okay, so then 0.37. Okay, so it's going to be in between these two. Okay, and so the 45 to get up to the 7, and then the 83 to get down. This one's going to be less of a change, so then it's going to be negative 0.3, and remember this is our R1 column. Okay, so negative 0.31. Okay, so now we have everything we need to substitute into our formula, because that's our z-score. Our x is going to be 135, and our mu is going to be 146. Okay, so 135 minus 146 divided by negative 0.31, okay, and then to the nearest tenth of a gram, when you plug that into your calculator and round to the nearest tenth, you get 35.5, okay, and we're talking grams, so don't forget your unit. All right, so for that question, we figured out the formula that we were going to use, and then we knew we had some things given to us. We just needed to find the z-score so that we could substitute that in. Okay, one more example. Okay, so, and keep in mind, we're basically doing the same thing over and over again. Just, you know, here we were solving for sigma, or standard deviation. Here we were solving for x. Okay, over here we were just doing the normal z-score stuff, both of those examples. Okay, now here we're going to be figuring out z-scores again, and we'll be using our standard deviation. Okay, so the marks of a large number of students have been represented on a standard normal distribution curve. The values given represent the number of students in each area. Okay, so right here we've got 452. Here we've got greater than 1250. Okay, so now things to remember about your standard bell curve. This line is the mean, okay? The area underneath this half represents 50% of your, in this case, population. Okay, so the total is 100%. So if you've got 1,250 on this side, okay, that means the total number of students, okay, is going to be 1,250 times 2. Okay, so 1,250 times 2. So that means we've got a total of 2,500 students. Okay, so that helps us because if we're looking for, you know, the percentage of everybody, like this example, how many students are represented by the area? Okay, so I guess I just answered it up there. So 1,250 is 50% of the data. Okay, so therefore, there are 1,250 times 2, or 2,500 students. Okay. Okay, so determine the value of z to the nearest hundredth. Okay, so we want to know the value of z here, so we need to find out the area underneath. Now, we know that there's 1,250 here, there's 452 here. So 1,250 plus our 452, okay, that's going to give us what we've got out of the total value. Okay, So we can figure out the probability of that by using this. So I add these two together and I divide by the total number of students. Okay? And so then I'm going to put that into my calculator. Sorry, somebody keeps trying to call me and I'm hanging up on them, which is mean, but I'll call them back. Okay, so then that gives me the percentage of my standard bell curve that's covered here, so 68.08%. Now remember, that's this area here. My z-score is going to represent to the left. So I need to subtract this from 1. Okay, so from here, my area of my z-score, okay, I'm going to subtract what I just calculated from 1, which is going to give me 0.3192. Okay, so then I'm going to go to my my standard deviation. So now, since I'm on the negative side, I'm grabbing my negative bell curve data. Okay, so we're looking for 3192. Oh, wow. Okay, so, oops, computer fell asleep. Wake up, computer. Okay, I see it right there. Okay, 3192. Is that the right? Okay, yeah. So that's going to be 0.4. And then, oops, sorry, you can't see, up to the 0.7. All right, so then z-score of negative 0.47. Okay. All right, so then that would be our final answer. So overall, I know some of this stuff can seem kind of tedious, but just make sure that you know how to A, manipulate this equation to solve for one of the unknowns, B, understand the relationship between the z-scores and the area underneath the standard normal distributed bell curve, and just be able to, when you're reading a question, like a word problem, be able to substitute in and say, like, okay, well, this represents my area underneath the graph, for example, etc. Okay? All right, so you guys can get working on your assignments, and I'll talk to you later. I'm going to go phone back whoever that was.